students, the purpose of this video is to make sure you feel comfortable with the idea of gathering and organizing data. So as I teach this lesson, I'm really going to try to make it a little personal. So why does math matter in life? Well, believe it or not, mathematics actually gives us the answer to a lot of questions that we have. So think of some super basic question that you might have, like how much money do I have, or how much is this item, how much money do I have left after I purchase the item. Like when you ask yourself those kind of questions, and I'm sure a lot of you do that every single time you go to the store, you are doing math, and you're using math to be able to solve an issue or a problem or a question that is at hand. And so a lot of researchers do the same thing, and in order to be able to answer their questions, they have to have a research. So every single day we're asking questions. Some are easy to answer, but some are going to require a little more thought and a little more investigation. In addition, thinking about different factors matters a lot. Different factors can impact situations in different ways. So if you think about maybe I am the owner of a pool business, and so I sell swimming pools, you know, there's a lot of factors that play a role in what my sales are going to look like. You know, where am I living at? Where is my business, or where is my headquarters located? Am I in Florida? Well, I'm probably going to sell a lot more pools. Am I in New York? Am I in Alaska? I'm probably not going to sell as many. What is the season? The season's going to affect how many pools I sell. Generally, I'm more likely to sell pools during warmer months because that's when people want to go swimming. But maybe it's super cold and I'm offering a great discount, like a Black Friday sale on the pools. And so that's going to affect my rate at which I'm able to sell. So a lot of different factors are going to play a role when trying to answer that type of question. So I'm really going to try to make this lesson personal to my individual research. And at the end, I'm going to give you an opportunity to explore on your own. And unfortunately, you'll have to explore by yourself. But I encourage you that once you explore, maybe go find a friend or go talk to somebody about what you developed and what you came up with. And just pick their brain about what they think and maybe what are their ideas. And just have a little conversation about the research that you may be interested in. So statistics is a branch of math that involves collecting, organizing, summarizing, and presenting data and drawing general conclusions from the data. You generally start with a question, you're going to gather some data, and then you'll analyze that data. What a lot of people don't realize is that if you go to college, you can actually major in math and major in statistics. There's different concentrations within the branches of mathematics. If you go to North Carolina State University, they actually have a department of mathematics and then a whole different department of statistics. And they run completely individually, independently, on their own, separate from one another. So it's definitely its own branch. And there's a lot of exploration and a lot of investigation in the field. So this may be something that strikes your interest. Don't rule it out. If you're kind of like, oh, I really don't like math, that doesn't necessarily mean that you won't like statistics. There's actually a whole class that's offered revolving around statistics. One option is MAT 152 or any other introductory statistics course at a local university in the area. Will teach the basics of starting with a question, gathering that data, and then how to actually go about analyzing it in the proper way. So you want to start by finding a question. Every sound research study has a question that is going to be posed. So when I went to doctoral school and I had to do my own individual research, I had to pose a question of my own. And the question that I came up with was, what factors play a role in the belief that a female mathematician has about their own mathematical success? So my research interests lie around females and minority females and their desire to pursue STEM. I'm particularly interested in females that have successfully, graduated or gone through their studies or are professionally working within the field. And so that's how I helped develop my question, was because I really wanted to understand, why is it that they were successful? What do they think they had that made them successful? Now, who are you going to study? Well, you have to determine who is the population and who is the sample. Now think about population like the big umbrella term. Population is all the participants of the study, everybody that you could be considering. So in my particular study, this would be every female mathematician in the world. That's the big umbrella term. But it's very unlikely that I'm going to have access to the population, right? Especially in my study, I can't access every female mathematician in the entire world. It just wouldn't be reasonable. I would never be able to complete the study. So instead, we use what is called a sample. Think about that. Think about a sample as a smaller subset of the population. It's a subgroup. So in my question, maybe I'm going to look at female mathematicians only at North Carolina public universities. So that's narrowing down. Instead of thinking about everybody in the entire world, I narrow it down and I say, all right, I'm looking at college instructors that are at public universities. Now, there are different sampling methods that we can follow, so I'm going to name just a few. There are several more, but we're not a statistics course, so we're not really going to go in depth with all of the different methods. Instead, I'm just going to briefly overview some of these methods. But again, if this is something that's intriguing or interesting to you, then I encourage you to take another introductory to statistics course, which will go much more in depth. So one of our sampling methods is a random sample. This is a selection that is made by chance where everyone in the population has an equal chance of being selected. So maybe I am looking at the population is my class that meets at 11 o'clock. And let's pretend that there are 30 students in that class. And I want to take a sample of that population, of that 30 students in the course. So maybe I would take down all of their names on a piece of paper and put it in a bucket, and then I would pick the number of individuals that I want out of that bucket. Every single name had an equal chance of being selected, right? And every single name, every member of the population was included inside of that bucket. That would be an example of a random sampling method. The next method is a systematic sampling method, You basically number all the members of the population and then you select every kth member. When I say kth, I'm just saying a certain member. So maybe every second member or third member or 10th member. So let's say I want to put everybody into groups, and so I count down my roster and every fourth person is going to be put into group 1. That would be considered a systematic sampling method. Another type of sampling method is called stratified. When a population is divided into groups where the members of each group have similar characteristics and a certain number of members from each group are going to be chosen at random, I have performed stratified sampling method. So for example, let's say I'm looking at Wake County public schools and private schools, and that's every single school that just that is inside of the Wake County border. And so I can then divide them up by category. So maybe I want to have titles, and then I'm going to name all the schools that fall underneath that title. So maybe I name all the large public schools and the large private schools and the small public schools and the small private schools. And then from every category, maybe I pick, 2 schools from each of those categories. So I first put things into groups, and then from those groups, I select an equal number of participants from each individual group. That is a stratified sampling method. And then I have the cluster sampling method. When I have a cluster sampling method, an existing group of subjects represents the population. I'm going to use that existing group for my sample. So for example, I may want to see how many computers arriving at the Apple store are defective. And so there's all these trucks and all these crates of computers, and one truck comes and it has one crate, and I pull that crate and I look at every single laptop on that crate, and I look at it and I say, oh wow, all of these are really great, they're all in great condition, and so that must mean all the Apple computers are great, they must all be wonderful. That would be cluster sampling. It a lot of times cluster sampling is similar to convenience. A convenience sample is just something that's pretty easy. So maybe I want to know what is people's I don't know what is individuals' favorite topping on a pizza. And instead of really truly asking a wide variety of people, maybe I just ask all of you in my class. That's real convenient, right? It's this convenient group of individuals that I have access to, and then whatever you all say, I make a analysis or a conclusion for every single person in the population, so everybody in the world. Now, how do you collect data? Well, data is the measurements or the observations that are gathered for an event under a study. So data can be both qualitative and quantitative in nature. When I think about qualitative, it sounds a lot like the word quality. These are going to be things that are more descriptive in nature. So just to make it easy, think about things like eye color, hair color, your name, what your hobby is, what your favorite dessert is and why, your opinions about your educational experience, your opinions about this course. Those would all be examples of qualitative data. Whereas quantitative data are numerical information. So these are going to be numbers. What's your age? What's your height? What's your weight? And both types of data are valuable. They give us different things. And as you advance in mathematics, we learn that we can analyze qualitative and quantitative data very differently. So you're going to want to think about what are the best ways to organize your data. And there's so many different methods, but for the purpose of this course, we're only going to talk about two methods. We'll look at frequency distributions and stem and leaf plots. So if you're interested in learning more, stay tuned for part 2 of this video, which will discuss frequency distributions and stem and leaf plots. Otherwise, I hope this gave you a better idea of what a research study is and what it involves. Again, remember that graduate students spend, multiple semesters thinking about what research really looks like. So this, of course, isn't a very extensive review, but just a quick, brief overview. As always, if you have questions or concerns, please don't hesitate to reach out, and I hope you all have a wonderful rest of your day.